Just a quick note before we get into this video. This video is only relevant to you if you are doing the DJI Caddx Vista version of the JB Xylo budget build. If you're doing the analog version, there's nothing in here for you. Go back to the playlist and find the next video that relates to the analog build. Now that they're gone. The next thing we need to do after installing the Caddx Vista in the quadcopter in the last video, we need to activate the Vista. We need to update the firmware on all our DJI gear. We need to connect it all up, and we need to do some Betaflight configuration. So let's get into it. And the first thing I'm going to do is start up the DJI Assistant 2 app. This is the app that's used to manage all the DJI FPV gear, your goggles, your controller, your Vista, your air unit, and so forth. I'll put a link to where to download that down in the video description. There are a bunch of different DJI apps for different DJI stuff, so it can actually be a little bit hard to find the one that you actually want to be working with. Then we're going to plug a USB-C connector into the USB port on the Caddx Vista. Note that is not the USB port over here on the flight controller. And then we are going to plug in a battery. A few seconds after we do that, we should see the DJI FPV Air Unit light, that's the Caddx Vista, appear in the DJI Assistant. And when you click that, you'll be given the opportunity to activate it and then to update the firmware on it. We'll click on that. We'll need to activate the device. Definitely have read and agreed to all these terms. Oh yeah. And then having done that, no, I'm not going to do the survey. Having done that, you should always update the firmware on all your DJI devices when you first get them. And they release firmware updates pretty regularly, so I might actually end up having to update the firmware on the goggles too. Once that's done, go ahead and unplug the quadcopter. You don't want to leave the Caddx Vista plugged in for too long on the bench because it gets super hot. And in fact, I'm going to unplug the quadcopter too. And the next thing I'm going to do is update the firmware on the controller. If you're not using the DJI controller, you can skip this step. To update the firmware on the controller, I need to turn it on. That's a short press and then a long press. That's how all DJI stuff works, but maybe you're new to DJI. Once it is powered up, I'm going to plug in USB. And the DJI FPV remote controller will appear, and I will go ahead and update the firmware on that as well. I'm already on the latest firmware, so it doesn't matter. And then lastly, I'm going to do the same thing for the DJI goggles. Quick note, you're going to want to use a 4S battery or smaller if you're using the DJI goggles V1. If you're using the DJI goggles V2, they can take up to a 6S battery with no problem. I'm going to go ahead and plug this in, and I'll plug the goggles into their USB port as well. While we're doing this, if you want to improve the performance of your DJI system a little bit, you can get these Axi HD antennas that stick to the front of the goggles. I've got a review of them up on my channel. I'll put a link to that in the video description if you want to check that out. Now that all the DJI hardware is on the latest firmware, the next thing to do is to bind the Vista and the controller, if you're using the controller, to the goggles. And you're going to do that by plugging in a battery to power up the Vista. After a short while, the status LED will turn green. And then you're going to press this button to the right of the status LED, which will put it into binding mode. And it'll go red. Next, I'm going to power up the goggles by plugging in a 4S battery. And to power up the goggles, I'm going to use a blunt-tipped object to press this bind button right here, right next to where the power plug plugs in. And you're going to hear that sound, beep, 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 beep. And then the status LED on the Vista will go green again, and you should have image in your goggles. I do. If you're using the DJI controller to bind it, first power it up. While it's doing that, I'm going to go back and again push the bind button on the Vista. The LED on the Vista will go red. And then to put the controller into binding mode, you're going to simultaneously press the record button, this right-hand button, and you're going to click the center detent of this jog wheel all at the same time. The LED will go blue and then green, indicating that it's bound. Next, we're going to plug a micro USB cable into the USB port on the flight controller, and we're going to shut down the DJI Assistant. And it's important that you do that because the DJI Assistant will interfere with the ability to use Betaflight. They'll fight over the COM port. Once we shut the DJI Assistant down in Betaflight, we can select the COM port that appeared when we plugged in the flight controller. A new COM port will appear. We'll select that COM port and then hit connect. Now at this point in the tutorial, the instructions between the analog version and the Caddx Vista version are similar in a lot of ways. And rather than make you watch two different videos, I'm going to take some of the old footage from the analog tutorial and insert it in here where it's relevant. And then I'm also going to shoot some new footage that pertains to the Vista where it's relevant. So if it looks like I'm a few months younger and it's from an old video, that's why. Please don't let that bother you. The first thing we're going to do is we're going to make a note of this target name, Xylo F4. It's really important that you remember this when you flash a flight controller. The next thing we're going to do is we're going to go to the CLI tab here on the left side, and we're going to back up the configuration of the flight controller. And I got to be honest with you, this flight controller is fresh out of the box. It doesn't have any configuration to back up. I'm only walking you through this step because someday you're going to be upgrading a flight controller that you've actually worked on. And I want you to learn that backing up a flight controller is an essential step of updating. Because when you update the flight controller, your configuration may be lost. And if you have a backup, then that's no big deal. So we're going to go to the CLI tab. And then we're going to type the word diff, D-I-F-F, space A-L-L, diff all. And we're going to hit enter. And some text is going to appear on screen. And then we're going to go down to the lower right-hand corner of the screen where there's a button, Save to File. And we're just going to save that to a file somewhere on the computer. We can name it, name it what configuration, what quadcopter it's from, something that'll help you remember what it is. We're going to save that to a text file, and now we've got our configuration backed up. After you've saved that file, you're going to go up and hit the disconnect button, and then you're going to go over here on the left to the firmware flasher tab. In this pull down menu, you're now going to scroll down and select the Xylo F4 target. It's very, very important that you select the correct target name when you flash your flight controller. And if you don't know what that is, do not proceed. You can go to the command line or you can connect to the flight controller and look just like we did. We're going to select Xylo F4 and we're going to select firmware version, the latest available at this time, that is 4.2.0. And then finally, we're going to enable full chip erase. Whenever you update the firmware, it's a good idea to do full chip erase. Sometimes it's not necessary, but it will never hurt, especially if you just backed up your configuration like I just showed you how to do. Finally, we're going to hit load firmware and then flash firmware. Now, when you hit that flash firmware button, one of two things is going to happen. If everything works correctly, here in the upper right-hand corner of the screen, this will change from the COM port to the word DFU, and DFU means that the flight controller is able to be flashed. Then you'll see erasing and flashing, which you see down here, and that is what happens when everything works. Now, hopefully for most of you guys, everything I've described so far has worked exactly as I've described it. If anything has gone wrong, like you plugged in the USB port and you didn't see a new serial port, or you couldn't connect to the serial port, or when you went to flash, it didn't flash. There may be a problem with your drivers. You may need to reinstall drivers. If you're on Windows, if you're on Mac OS or Linux, you don't need to install drivers. There may be a problem with your USB cable. Some USB cables are charge only. They're not used for data. Like if it came with your phone, it may be charge only. Try a different USB cable. There are various things you can try to do to get it sorted, but hopefully it's worked to this point and we're going to proceed. Here in this pull down menu, DFU has gone away and COM3 is back. We're going to hit connect, and Betaflight is going to ask us whether we want to apply custom defaults. The short version of the story is you should always say yes to this. Just say apply custom default. Well, then why doesn't it just do it for you? Just hit apply custom defaults button. Having done that, we're going to hit connect again. We're going to get another warning that the accelerometer is enabled, but it's not calibrated. So we're going to close that window, and right here in the setup tab, you're going to set the quadcopter down on a flat and level surface, and then you're going to hit the calibrate accelerometer button and wait for that to finish. Now, typically you'll only have to do this once. Sometimes after like a hard crash or a smack, the accelerometer will get out of calibration and you may need to calibrate it again, but this is not something that you need to do like every time you fly. The next thing I want you to do is go to the configuration tab and follow along with some basic setup that we're going to do here. I want to do something a little different in this tutorial. A lot of times when I do these tutorials, I'll go really deep in depth about why we're making the changes we're making, and it can be a little overwhelming for people. Maybe some people love it, some people find it a little overwhelming. For this one, I kind of just want to walk you through the changes without going super in depth into the background about why the changes are being made and get you sort of through this experience and enjoying actually flying the quadcopter as fast as possible. So just follow along with me here. So the first thing I want you to do is over here in the system configuration section, I want you to change the PID loop frequency from 8K to 4K. Up in the upper right, I want you to enable bidirectional D-shot. And then here in the arming section, I want you to change the maximum arm angle from 25 degrees to 180 degrees. I need to tell you what that's doing because it is disabling a small safety feature. And if I'm going to encourage you to like drive without your seatbelt, you should at least know what you're doing. The maximum arming angle prevents the quadcopter from arming when it is not flat and level. And the idea is that if you are like carrying the quadcopter in your hand with the battery plugged in, which you should not do, and then you accidentally flip the arming switch and the quadcopter would arm, well, it'll prevent it from arming and maybe save you from getting cut or injured. The problem with this setting is that if you're ever like trying to take off on a hill or your quadcopter isn't quite level, or you crashed and it's upside down or something and you won't be able to get back into the air. Setting this max arm angle to 180 disables the maximum arming angle. I do this on all of my quadcopters, and I take other precautions to prevent myself from accidentally arming the quad when I didn't mean to and getting hurt. I would suggest that you do the same, but know that you're disabling a safety feature and make sure that you take other safety precautions so the quadcopter doesn't hurt you if you choose to do this. Back over here on the left side, I want you to scroll down and I want you to enable the telemetry feature, and I want you to enable the RX set and RX lost D-shot beacon configuration. We don't have a buzzer on this quad, and a buzzer is very helpful if you like crash your quad in the grass and you can't find it. So this will allow the motors to beep. The motors are capable of beeping, kind of like a beeper, and it's a good alternative if you don't have a buzzer on the quad. We're going to be doing save and reboot a lot, and each time we do, the quadcopter will disconnect from the computer and we'll need to go back and hit connect. So here's a little tip. Enable the auto connect button and it will automatically reconnect when it reboots. The other thing I want you to do is hit this gear icon, and I want you to permanently enable expert mode. Trust me. I also suggest that you choose reopen last tab on connect, which will reconnect to the last tab that we were on, right back where we left off. Finally, if you prefer dark mode, you can turn dark mode on. A lot of people are liking dark mode apps these days. You have the choice. What does auto do? Put it in dark mode if it's like nighttime? I don't know about that. Let's just, there we go, dark mode. Okay, I'm going to reconnect. And when I reconnect, I'll be right back here in the ports tab, because I enabled that reconnect to same tab option, and I can just double check that all those changes that I made are still made. And yep, they're all still there. The next thing we're going to do is we're going to set up the receiver. And the receiver is the thing on the quadcopter that receives the control inputs from the controller here. And in this case, the receiver is, well, it basically is the Caddx Vista. The Vista is both the receiver and the video transmitter all at once. So in Betaflight, we're going to go to the ports tab. What we want to do is we want to have serial RX enabled on UART 1. Oh, it is. That's fantastic. And down here for UART 4, we want to enable the configuration/MSP option. And that's going to be it. You should also have the ESC sensor input enabled on UART 2, but I believe that's on by default. I don't think you need to change that at all. Then in the lower right, I'm going to hit save and reboot. Now at this point, we're going to go on and we're going to set up the DJI controller. But if you are not using the DJI controller, then you're going to need to go back over to the other video, Betaflight 4.2 complete setup. And I'm sorry that this is a little confusing, but I can't put this information in. I can't put both of this information in the same video. It would be even more confusing. So to set up your receiver, if you are not using the DJI controller, so you're going to go to this video, and I want you to click right down here where it'll bring up the chapters in the video. And you're going to go to Set up Receiver, Configure Endpoints, Set up Aux Modes, Set up Smart Port Telemetry, Set up... No, you're not going to do that part. That's where you're going to stop. Okay? You're going to do those sections, and at that point, you should have your receiver and your controller working. The next thing we're going to do is go to the configuration tab, and we need to go down to the receiver section here. We need to make sure the receiver mode is serial-based receiver, and it is by default. And we're going to make sure the serial receiver provider is SBus. If yours doesn't look like that, go ahead and make that change, and then in the lower right, save and reboot. The next thing I'd like you to do is to go to the CLI tab. And I'm going to ask you to put in a command here that is going to give you just a little bit lower latency on your controlling. This is something that a lot of people, especially beginners, might not notice, but it's good practice and there's no reason not to have you do it as long as we're here. What I'd like you to do is in the CLI type set SBus underscore baud underscore fast equals on. Just like you see me typing there, and hit enter. And then type the word save. After you do that, go into your DJI goggles, go to the device menu, and change the protocol option to be SBus baud fast or fast SBus as well. You should see that in the receiver tab, when you move the sticks on the controller, all the channels are moving. If you don't have movement when you move the sticks, then something has gone wrong. You may need to go back and recheck all of the steps. One more thing I'd like you to check before we move on, and that is that the channel mapping is correct. And what that means is that when you raise the throttle, which is the left stick up and down, the throttle channel moves in the receiver tab. When you move the yaw axis, which is left stick left and right, the yaw channel moves. The pitch axis is right stick up and down, and the pitch channel is moving. And the roll axis is right stick left and right, and the roll channel is moving. If that is not how yours is, and I think it should be because I think the default channel mapping is correct for DJI, but if yours is not that way, go up to this channel map parameter and change it to the FreeSky Futaba High-Tech option, which should cause it to read AETR1234. Go ahead and make that change and hit save, and then your channels should move exactly correctly. The next thing we need to do is set up our aux modes or auxiliary modes. And aux modes are how, for example, when you flip a switch on the controller and the quadcopter arms and gets ready to fly, that's an aux mode that is causing that to happen. When you flip a switch and the quadcopter goes into auto level mode versus acro mode, that's an aux mode that's controlling that. When you flip a switch and the buzzer goes off to help you find your quadcopter after you crash it somewhere and maybe you can't find it, that's an aux mode that does that. We're going to set up aux modes here in the Betaflight Modes tab. And the first thing I want you to do is make sure that this hide unused modes option is disabled for now. And the process of setting up the modes is pretty simple. Let me walk you through it. I'm going to start with the arming mode. I'm going to click the add range button, and then I'm going to flip the switch that I want to use to arm the quadcopter. And just follow along with me. If you end up having preferences for how you want to set up your switches, you can change it later if you want, but for now, just follow along. I'm going to have you set it up exactly like I do. I'm going to use the top left switch to arm the quadcopter, and I am going to push that switch away from me to arm. So the first thing I'm going to do is I'm going to just move that switch one time. And when I do that, you should see aux1 gets filled in here. It has picked up which switch I have moved, and we're going to use that switch now to control this aux mode. And you can see that as I move that switch, this little yellow tick mark moves up and down, reflecting the current channel position. So what I'm going to do is I'm going to put that switch in the arm position, which in my case, I'm going to suggest you make that be pushed away from you, push away to arm. And then I'm going to click drag and move this yellow slider so it is on top of that little yellow tick mark. And I'm going to hit save. And now the quadcopter will be disarmed when I pull the switch toward me, and it will be armed when I push the switch away from me. The next thing I'd like you to do is to add angle mode. Angle mode is auto level mode. A lot of beginners prefer to fly in auto level mode. We're going to add angle mode. I'm just going to hit add range. And what I'd like to do is I would like you to use this right hand switch on the front of the radio for angle mode. I'm going to move that switch one time. aux3 is going to get picked up here. And I'm going to leave that in the middle. I'm going to use this middle position of this 3-position switch to activate angle mode. So we're done. We're going to hit save. And you can see that when I push that switch up, angle mode is disabled. When I put that switch in the middle position, angle mode activates. And in the down position, it's disabled again. Scroll down until you find the beeper mode. Add range. For the beeper, I'd like to use this right-hand switch. I'm going to move that switch. It's going to pick up aux 4 right here. And then again, I'm going to put that switch into the position that I want to use to activate the buzzer. And so the switch is by default going to be in the pushed away position. And then I'm going to pull it towards me to activate the buzzer. So I'm going to put that in the pulled towards me position. I'm going to look at where the yellow tick mark is when the switch is in that position. And I'm going to move this slider to cover that yellow tick mark and hit save. Oh, look, it's working. So now I can activate and deactivate the buzzer by moving that switch. I'm going to continue to scroll down until I find the flip over after crash mode. I'm going to hit add range, and I like to put the flip crash mode on this switch right here. What's flip crash mode? If the quadcopter crashes and it's upside down, flip crash mode will reverse the props so you can flip the quadcopter back over again and take off again. It's useful for getting quadcopters out of places where maybe you aren't able to walk to them easily and get the back. Or if a quad gets stuck in a tree, flip crash mode is useful for shaking it out of a tree. This is not something that beginners may choose to use right off, but it's part of my standard setup and I want to share it with you. So I like to put flip crash mode on the same switch as angle mode. In the middle position, it'll be angle mode. In the down position, it'll be flip crash mode. You can see that by moving the switch, I have picked up aux 3. And I'm going to put the switch in the down position. I'm going to look at where that yellow tick mark is. And I'm going to drag this slider to cover the yellow tick mark and hit save. Now at this point, almost everything I need to set up for the aux modes has already been set up. So I'm going to scroll up to the top of this window and I'm going to hide unused modes. And your screen should look pretty much exactly like mine. And I can double check my modes, put the switches in the up position, except for the arm switch, which I like to pull towards me to disarm. And now push it away, we arm. Arming is disabled at the moment because we're plugged into USB and we're working with the quad on the bench. It won't let us arm. But arming goes red. Angle mode in the middle position for this switch, and flip crash mode in the down position for that switch, and buzzer for the right shoulder switch. There we go. The next thing we're going to do is set up our motors. And a major thing that we haven't done to this moment is verify that the motors are spinning the correct direction. The motors have to be spinning the right direction or the quadcopter will not fly. And the direction that the flight controller expects the motors to be spinning is given here in this diagram in the motors tab. So we need to spin the motors one by one and verify that they are going that direction. The way we're going to do that is first we are going to make sure your props are off. Props should be off because I haven't told you to put them on yet, but if your props are on for some reason, take them off. This is not safe to do with props on. We're going to click this button. I understand the risks. Props are removed. And then I'm just going to single click on the master tab. And then I'm going to press the up arrow key on my keyboard and just hold that until the motors begin to spin. And now all of the motors are spinning. Then I need to check the motors one by one and see that they're spinning the right way. And I find doing this with my finger to be a little misleading sometimes. So I like to take like a piece of paper, a business card, a battery strap, and hold it up against the motors one by one. Okay, that is spinning the wrong direction. Motor number 2, the front right motor, is spinning the wrong direction. Motor number 1 is spinning the correct direction. Motor number 3 is spinning the wrong direction. Motor number 4 is spinning the right direction. So for me, motors 2 and 3 are spinning the wrong direction. That is not necessarily true for you, depending on exactly how you soldered up your ESC wires. If you soldered your ESC wires different than me, you may have different motors spinning the wrong direction. You just need to note which motors need to be reversed to spin the other way. The other thing I want to do is I want to check the motor numbers 1, 2, 3, and 4, and make sure that the positions are correct. And they should be, because we installed our flight controller and our ESC facing the correct direction. But let's just double check and make sure that's true. So slider number 1 should be the back right motor. It is. Slider 2 should be the front right. It is. 3 should be the back left. It is. And 4 should be the front left. It is. Okay. That's a check you might want to do. You should do that check on every build. On this build, it didn't turn out to be necessary, but if we were to rotate the ESC or the flight controller, then the motors might need to be remapped. So now I'm going to disconnect my flight controller, and I'm going to go to BLHeli Suite 32, which is the other app that I had you download earlier in this series. I'm going to select my COM port, whichever COM port the flight controller is plugged into, and I'm going to hit connect. When I hit connect, the screen should change to look like this. The connect button will turn into a disconnect button and the COM port will gray out. And then I'm going to hit read setup. And I should get a screen like this. Now I need to reverse motors 2 and 3, and here's how I'm going to do that. Down here at the bottom, I'm going to right click on ESC number 2 to select it and it only. And I'm going to change the motor direction from normal to reversed. Then I'm going to hit right setup. Then I'm going to right click on ESC number 3 and change the motor direction to reversed and right setup. Then I'm going to left click to reselect all 4 ESCs and hit read setup. Then I'm going to hit the check button, and that should check all 4 ESCs, and I can verify that ESCs 3 and 2 show motor direction reversed. There are a couple other changes I want you to make here. One of them is I want you to change the PWM frequency from 48 to 24. And I want you to change the motor timing to 23. And then I want you to hit right setup. And the last thing we can do here is go to the ESC overview tab, and we can verify the changes that we've made are in bold. So the PWM frequency has changed to 24. The motor timing has changed to 23 for all 4 of the ESCs, and the 2 ESCs that I previously noted are showing as reversed. The last thing we're going to do is we're going to set up the on-screen display. In other words, you can get certain information in your goggles that is useful when you're flying. You're going to do that here in the OSD tab. And this is one of those cases where there's basically infinite variety in exactly how you set it up. You can turn on and off individual OSD elements, like, for example, this is the battery average cell voltage. That helps you make sure that you're not over discharging your batteries when you go to fly. And you can see that as I tick this box, that turns on and off. And you can drag it around, and that'll change where it appears on your screen. Now, rather than sort of leave you to figure it out for yourself, I'd like to give you a setup that I use on all my DJI quads, and it's actually really easy for you to get that set up. So what you're going to do is first, here in the OSD tab, just turn off everything. Just turn it all off, right? So there's nothing visible on the screen, and hit save. Down in the video description, I'm going to put a link to a text file, and it is this, which is my OSD configuration for DJI with GPS. And it's all this text. And basically, you're just going to copy paste that text. Copy. And you're going to go into the CLI. And you're going to paste that text in. And hit enter. And then you're going to type the word save. And when you do that, your flight controller will reboot, and when you come back to the OSD tab, your OSD should look like this. Now this looks a little weird, but when you see it in the DJI goggles, it actually lays out, I think, pretty well. You may notice that there's some elements here that are not relevant to our quadcopter. This is a latitude and longitude element. This is GPS satellites. I put these things in my OSD because some of the quadcopters that I fly have GPS on them, and I want to be able to see that stuff. If you don't want to see that stuff, you can go through here and you can turn off GPS latitude, GPS longitude, GPS sats, GPS speed, home direction, and home distance. And altitude. Where's altitude? And altitude. So you can turn those things off and it'll clean your display up a little bit. If you choose to do that, just go ahead and hit save when you're done, down in the lower right. You're also going to need to go into your goggles and go to Settings, Display, and make sure that Show Custom OSD is on in order to see this information. And that brings us to the end of the Vista specific instructions for this build. At this point, you should be able to continue the playlist pretty much exactly as the folks who are building analog did. Enjoy.